Hello everyone. In this video, let's discuss how to write a program to find number complement. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros in its binary representation. For example, the integer 5 is 101 in binary representation and its complement. The complement is we have to flip ones to zeros and zeros to ones. That is 0, 1, 0, which is the integer 2. Given an integer, return its complement. Okay, fine. Now let's discuss the example. So here they have given the input value as 5. The binary value of 5 is 101. When I flip all the binary digits, I will be getting the binary value as 010, which is corresponding to the integer value of 2. So the output is 2. Let's take the input 1. So the output is 0. So let's discuss the logic in detail. So before going to this logic, we have to know how to convert a binary number into a decimal number and a decimal number into a binary number. So let's take the input value called 5. Okay, so I'm going to convert this number into binary number. Let's discuss how to convert this number into binary number. So we'll take 5 divided by 2. So when 5 is divided by 2, I'll get my quotient value as 2. Fine. And my remainder value, I'll keep it here. Similarly, I'll take the value 2. Okay, divide by 2, so 1 2s are 2 and my remainder is 0. So from down onwards, I have to take all the representations, that is 1, 0, 1. This is the binary representation of the value called 5. Now we have to know how to convert the binary number into a decimal number. So that logic is pretty simple. So here I'll take this binary value 1, that will be multiplied by 2 power 0. So 2 power 0 value is 1. 1 into 1, 1 I'll get. Then I'll go to the next digit. I'll take this 0. This 0 will be multiplied by 2 power 1. So the value is 0 because 2 power 1 value is 2. But when I multiply it by 0, I'll get my value is 0. Next I'll take the next digit called 1. So 1 into 2 power 2. So 2 power 2, the value is 4. 4 into 1, that is 4. Now I have to sum all the terms. 1 plus 4, 5. So we have got the decimal value of the binary representation. So this is the logic to convert binary number into a decimal number and decimal number into a binary number. So the reason why we are discussing that in the sense, here we have to flip all the ones to zeros and zeros to ones of the binary representation of 5. That is why this logic is most important. Now let's discuss the logic in detail. Okay, let's take the input value 5. We have taken the input value 5. So first what I have to do, I have to convert this decimal number into binary number. So I'll divide the number by 2. Okay, when I divide the number by 2, I'll get the quotient value as 2 and my remainder is 1. So when I get the remainder value as 1, what I'll be doing? I'll convert this 1 into 0. I'll convert this 1 into 0. After converting this 1 into 0, what I have to do is, I have to take this 0, I have to multiply it with 2 power 0. The value I will be getting it as 0. This 0 I will be adding it with one variable called ans. So I will be taking a variable called ans. Initially I will store my value as 0. So 0 plus 0, the value is 0 now. Now what I will do, I will be going for the next step. This 2 will be divided by 2. I will get my quotient value as 1 and my remainder value is 0. So when I get my remainder value as 0, I will convert this 0 into 1. I will flip this 0 into 1. Then I will be adding it with the previous answer value. So 1 into, this time I have to go with the value called 2 power 1. So 1 into 2 power 1, the value is 2. This 2 will be added with the answer. So 0 plus 2, I will get my value as 2. Why? Because finally I have to get the decimal value as my output value. That is why we are doing this. Then I have got my value as 1. So when I flip this 1, I will get my value as 0. So this 0 will be taken, that is multiplied by 2 power 2. So 2 power 2 value is 4, multiplied by 0, I will have my value as 0. This 0 has to be added with the ans value. So 2 plus 0, the value is 2. So finally I will return my variable called ans, the value is 2. This is the logic of the program. So here we have seen how to convert the decimal number into binary number and binary number into decimal number. Here we have solved as per the logic of the program. I am converting the number into binary. After converting the number into binary, I am flipping the bit. After flipping the bit, I am trying to convert it to a decimal number. Now let's try to implement this as a program. So first thing what I'll be doing, I'll be taking a variable called ans to store the result. Or do we take yes, ans equal to 0. Fine. Now I'll take a if condition. Why? Because if my input value is equal to 0, directly I can return the value as 1. Else, I have one more condition, that else if my input value is equal to 1, I can return directly it as 0. Because flipping 1 to 0, 0 to 1, that is the logic here. After this, I will be taking a for loop. Because I have to extract one digit, right? So, I'll instead of taking a for loop, I'll take a while loop. While num not equal to 0. Because until the input value num becomes 0, I have to repeat the process. So, I am taking num not equal to 0. Now, I have to extract the digit. So, here what I have done, I am dividing it by 2, I am getting the remainder value. So, if num modulus 2 equal to 1. So when I am dividing the number by 1, if I get my remainder as 1, what I have to do? I have to change that to 0, right? Further, I will be taking one more variable, int x. Okay. So I'll convert it into 0. So when the remainder is equal to 1, I'll convert that to 0. If the remainder is equal to 0, I'll convert it into 1. Okay. When I'm dividing by 2, I'll get the remainder value. If the remainder is equal to 1, I'm converting it to 0. If it is equal to 0, I'll go to else case, I'm converting it to 1. Now I have to convert that into a decimal number. So for that, answer equal to answer plus, okay. So the remainder what I have got, that should be multiplied with 2 power 0. So here I'm taking a function called math.power 2 comma 2 comma. So each and every time the value has to be incremented from 0 to 1, 1 to 2, 2 to 3, right? So for that I'll be taking one more variable called index. So I'll initialize the value as 0. Now 2 power index. So 2 power 0. Okay. That has to be multiplied by 2. So that has to be multiplied with the variable x. Because what I have done here, 0 into 2 power 0. So the 0 states x, 2 power 0 value, that will be added with the variable called ans. That's it. After this step, what I have to do? I have to divide the input value num by 2 so that I'll get my quotient value. So num equal to num divided by 2. After this, I have to do one more step, that is nothing but when I go for the next iteration, index value has to be incremented because 2 power 0, next step 2 power 1, next step 2 power 2. So I'll increment by index. Index equal to index plus 1. That's it. This is the logic of the program. Let's return the variable ans once the function execution got done. Let's run this code. There is an error. Okay. The error is here it returns the double value, not integer value. So I'm typecasting it to integer. Because power function will return me the value with double. That is why I'm getting an error saying that possibly lost the conversion from double to int. Now let's run the code. Yes, it passes its cases. In the previous case, I'm trying to add an integer value with a double value. That is why I've got an error. Here what I have done, I'm typecasting the double value into integer, just converting double value into integer value. This is what called as typecasting. Let's submit the code. As it passes the test cases. That's all.